Hey guys, welcome back. This is a continuation of my previous Basics of Unity tutorial. In the first one, I went over the first 5 main windows that you have. So Scene, Game, Hierarchy, Project, and Inspector. This time I'm just going to go over the toolbar up here at the top and have a really basic overview of the additional windows down here. So light mapping, occlusion, culling, navigation, and I'll probably go into the profiler too. Yeah, we'll just start with file since it's the first one. In the file menu, it's basically just the basic file menu you get with any program. Just allows you to create new projects, new scenes, lets you modify certain settings. This is where you modify your build settings when you're ready to export your project or make a test build. Yeah, the build settings, basically you just choose your platform, your architecture, and you can also modify your player settings from here. I'll go into the player settings a little bit more in a later tutorial, just because it's a little bit more complicated just to tweak things the right way depending on what you're trying to achieve with your project. The next window over is your edit, or the next toolbar over is your edit tool, where you basically just have your basic undo and redo, cut, copy, and paste, your specific project settings. So here you can change how the audio functions within Unity for this project, the physics. You can manipulate and set up specific quality settings, yeah, that's basically anything you need to change about your project is right here in the edit menu. You can also emulate different graphics properties and network settings, just so you can figure out what your game's going to look like on lower end graphics, or if your grandma's on dial-up and you want her to play your game on the web browser, you can figure out how long it's going to take for her to download it on her AOL. And you can also change the preferences for Unity. And in your preferences menu, you can tell it whether or not you want to automatically refresh every time an asset's imported into your project. The project window, so every time you open up Unity, if it's checked, a little window will come up and tell you which project you want to open up, just in case you're working on multiple projects. It's a little bit more convenient that way. If you're just working on one specific, you can just uncheck it and it'll automatically open up the last scene you loaded. Compress assets on import. It's useful in some ways it's not. If it's checked off, it'll automatically try and find the best format for it to be compressed in, which is useful. But if you're working on a project and your artist decides to update every single texture in your project, and he puts it on the repository and you grab it, suddenly Unity's taking an hour to open up because it's trying to recompress every single texture. So it has its uses. So you'll know, it'll decrease your game size when you're exporting, and things will run a little bit smoother in the editor because it doesn't have so much video RAM to take up. But on import, it takes a little bit longer. Editor analytics basically just tells Unity how you're using the editor, kind of helps them improve it. And showing asset store hits. When you're searching in your project, you can, let's type in gun. You can search the asset store and it'll bring up a list of asset store assets that are tagged with gun, like right here. All of our free assets, and there's paid assets as well. So that's actually pretty handy. Verify saving assets will just ask you if you're sure you want to save, and skin is just how you want it to look. In external tools, you can choose which script editor you want, whether you want to use MonoDevelop or you prefer Visual Studio or you're using Sharp Develop or anything like that. You can specifically tell it to open up that editor whenever you double click on a script or create a new one. And the editor attaching is basically just attaching the editor to the script editor, so you can create breakpoints in your code and figure out what values are or why something's doing something at a certain point at a specific frame in your game. It's really handy for debugging. The image application, basically it's just when you double click on an image in your project, it'll open it up in whatever image application you have. You can tell it to use a specific one, or if you just leave it as open by file extension, it'll just use the Windows default one. So if you have Photoshop or GIMP as your default, it'll just open those up. And version control, that's if you have a specific version control right in Unity, like Perforce or something like that. Those are more for bigger projects. And then the last one is just where you keep your Android SDK if you're building for mobile on Android. Then here's just you can fiddle around with the colors of just things within the editor. I don't really find it that handy. I don't see the point. It looks fine the way it is. And you can also change the shortcuts for Unity here as well. If you like things to work a specific way, if you're used to one editor, you can basically set it up the exact same way here. So that way it makes it a little bit more convenient for you to swap back and forth. If you're, say, a modeler in 3ds Max or Blender and you want Unity to move the camera around the exact same way, you can do that here. Cache server basically is if you have the asset server license, you host a server that has basically all your assets and your levels set up, and as you're updating stuff within your level, you can update the server, and then whoever else is connected to that server will see the updates in real time. That would actually be really cool to see. I've never tried it out, but I think that would be pretty awesome to try. And packages, I have never used this, so I actually don't even know what it does. I'll be completely honest with you. And yeah, that was the Unity preferences. So basically, anything you want to change within the Unity project can be found in the edit settings. The assets menu is where you can create new, scripts, materials, animations that'll be located in your project. You can import any assets. You can export a package. So if you have multiple objects in your project that you want to export, say you have a couple scripts that you created for a project that you'll find really useful for future projects. You can take all those scripts and any assets that go with them, and you can select them, export the package with just those objects, and then any future project that you do, you can import that package and all the scripts and assets will be there, right there. It's basically just a convenience thing. You can also export the package for personal sales, or putting things up on the asset store, that sort of thing. The select dependencies, basically if you had an object in here and you hit select dependencies, it'll basically just select all the assets that it requires to look the way it looks and run the way it does. So it'll select all the scripts, materials, and textures that are required by that object. And Reimport all is mostly useful for if you're having a huge issue with your project, something weird and random goes awry, and your project is just messed. You can try and re-import all the assets. Sometimes that fixes the issue. It's basically just an emergency thing. There's no real need to do it any other time. And then sync the mono-develop project basically just syncs up Unity with whatever mono-develop project is in the project. So settings, new scripts will automatically be added to the assemblies that the mono-develop project uses. And it's just make sure that while you're working in mono-develop, everything is up to date. That's basically what that's used for. Now, the GameObject tool basically is for creating objects within the scene. So while the assets was creating objects for your project, GameObject creates them right in the current scene. So creating an empty object will just create basically just a transform that you can move around, something that you can parent objects underneath, that doesn't really... it's basically like creating a container or just an object that you want to attach other stuff to. Specific scripts, if you're creating like a manager object or something like that. That's where you would use your empty objects. Creating other, you can create your particle systems, lights, random primitive shapes like cubes, any sprites if you're doing stuff in 2D, cloth, reverb zones if you want your footsteps to sound differently if you're on a bridge or on echoey room, your trains, basically anything you want to do with your project, or any objects you want to bring into or create for this scene, you can do from this menu. The clear parent basically unparents the object. You can also just drag the object out, so do whatever you please. Move to view basically doesn't do what I thought it did. And align with view, it will move the object to the current scene camera's position and rotation. So this is useful if you want a camera in your scene to look specifically where your camera is. Like if I wanted to look, right here for whatever reason, I can select the camera, go to GameObject, align with view, and now it's looking in the exact same direction that the scene camera was. So it's pretty good for getting cameras in the scene set up. If you're trying to do something cinematic, I guess, you could use it to get things rolling. It's useful in that sense. And then align view to selected will move the actual scene camera to whatever direction the object is. So I can also see the use for that where you're trying to you just can't quite get the scene view where you want it. Sometimes it's a little touchy and acts weird, so if you wanted to align with your camera just to see what's going on, bam, it's there. Fancy. Now the component menu allows you to actually add components to whichever game object is selected. So if I want to add, say, particle system to this cube, it's right there. And from here you can have any sort of effect, add your rigid bodies if you're trying to do stuff with physics. If you're doing stuff with nav meshes that Unity has, you can make your agents and obstacles and all of that stuff. Any sort of audio sources, and attaching your random stuff, whether you're doing networking or you need some animations, you can basically do that all from the component menu. In addition, you can, if you're creating your own scripts, you can add them to the component menu. So let's just do a quick empty class. Let's do just random letters. Why not? And we'll open that up and we'll add it to the component menu. Today. Alright, so it'll automatically go into the component menu under scripts, but if you want something specific, say you have specific AI scripts and you want them to be located in a certain menu, you can do that by adding an attribute to the top of the class. So I'm doing this in C#. So to add a component to add an attribute to a class, you're going to start with square brackets, and inside those square brackets we'll type in add component menu, and in regular brackets, in quotations, we'll just call it AI, and then for every submenu you want, you just add a slash. So AI slash derp slash my script. Okay, and then you save that, bring that back into Unity, and in the component, now there's the AI menu, derp, and my script. Okay, simple enough. Really makes it easier for you to organize your scripts within the component menu. Especially if you have a lot. Sometimes it's worth just taking the 30 seconds on each script to do it. Yeah, it's actually really easy to extend the Unity editor. It's one thing I like about Unity is just how easy it is to get things going within the editor. But that's basically it for the component menu. It's where you can add your scripts, and if you want to add specific menus, you just add the component menu attribute to the top of your script and give it the path. Really easy. Now next is the window menu, and basically next window, previous window, doesn't really do much unless you have, I guess, multiple of the same window, I'm guessing. Previous, next, nothing. Sweet. Alright, so that's pretty much, must have a very specific use. Then there's the layouts, where we went over this last time, where you can choose your specific layout, whatever you please, which made Totally Awesome, so we're going to use the Totally Awesome layout. And you can also, if you accidentally closed out one of these tabs, or one of these views, you can get them back through the window menu. So I just closed out scene and game, so I'll just create the scene view, and we'll create the game view. And then they're back. It's a little messy, so we'll just choose our old layout again, and we're back. Yay. Alright. Now, the first view I'm going to go over that I didn't go over last time was the profiler. You only get this if you're in Pro. But to me, I think the profiler is pretty much worth the Pro license on its own. When you're getting towards the end of your project and you're trying to tweak things, make it as efficient as possible, the profiler helps a lot. Basically, to use it, all you do is hit record and hit play, and anything that happens within the scene will show up in this view. And you get more than just the CPU usage as well. There's additional profilers, so you can see what the graphics card is doing, how many objects are being rendered, your memory usage. So basically anything you really want to know about how your project is faring with frame rate, how much time a specific script is using, you can basically do it here. and it's like I said, it's worth the pro license on its own. You would be surprised at how many bottlenecks something like this will find without you even realizing it beforehand. You could have one script that's taking up the entire frame, and it could be just an additional loop that doesn't need to be there, that you would never have realized was causing the issue unless you had the profiler going. And in addition to just basic recording, you can do a deep profile, and this will go right into each individual script that you create and tell you which function is taking up which amount of the frame time, so you can see which specific function is actually causing any issues. So, it's pretty awesome. And if also, before I forget, if you're working on mobile devices, or just you exported a project to like a Windows executable or something, you can change the active profiler. And say I had my my tablet with my current game on it, I could select the active profiler, and as long as my tablet is connected to the computer or to my wireless network, it'll show up here, and I could see what basically how things are running on my tablet itself instead of within the editor. So you can do actual profiling on devices instead of just within your editor, because usually the computer you're on is a little bit more powerful than, say, an iPad 2 or some random Android tablet, because you never know what's in those. And it's so you can see specifically where something is going a little bit awry compared to where it was on the computer, because the architectures are different as well. So where something might run perfectly fine on your computer, on the tablet it might run a little bit slower, just because of the lower powered graphics card, the limited amount of RAM, the processors are usually slower. So that's actually really, really handy when you're trying to when you're on the last stretch and you're trying to figure out why your Android or iPhone project is crashing or running at like 15 frames a second. So yeah, I can go on and on about why the profiler is awesome and why you should get it, or why you should get Pro just for the profiler, but I'll end it there before I start ranting more than I have. The asset store, if you're brand new to Unity, you don't know what the asset store is. Once it loads, the asset store is basically for the community that uses Unity to put assets up for sale or for free for any other developer to use. So if you're working on a first-person shooter and you really need a specific gun, you can check at the asset store. Let's say I needed an M16. You can just search that in there, and anyone that's created an M16 model will show up here, and you can pick and choose which ones you want. You can see any information you want. There's preview pictures. People can leave reviews if it's a good or if it's a crappy project or asset, and it's a good way for some people to make money, and it's a good way to speed your development along, because there's also scripts and tools and services that you can get through the asset store that can save you quite a bit of time if you're in a bit of a pinch and you need to get things going really quickly, or if you're looking for entire replacements. So like if you're looking for Unity's GUI, for example, right now it's kind of it's easy to do stuff, but I actually haven't used it in a while. I know for a while there it was really, really rough on mobile devices. So if you need specific ones, stuff like NGUI or iGUI, people have created their own GUI systems within Unity to kind of get around that issue. Just stuff like that. But yeah, basically if you're looking for an asset or something specific, there's a pretty good chance that the asset store has it. People have been putting stuff on here for years now, so if there's a hole that Unity has, someone's probably filled it. And next, I'll go over these another time. The animator could probably use its own video itself, just on how to use it and what you can do with it. Sprite Editor is new to 4.3, only useful if you're doing 2D stuff, and it's still kind of, like it says, developer preview. It's there, but there's still a few issues with it, I'm assuming. I haven't personally tried doing anything with it yet. I haven't had a reason to. So I'll go over these two another time. So skipping down, we'll go into light mapping. So we'll just go over here. Light mapping basically lets you take all the lights in the scene and bake them into a texture that will be drawn over top of the texture that is already on the objects. Kind of a bad way to explain it, but what light mapping lets you do is it lets you get really nice lighting. So you can have like 100,000 lights in your scene, and if you bake them into a texture, you'll get all of the light detail without the expense of having real-time lighting on every single object. You lose the real-time shadows, but the cost savings on your CPU and graphics card and everything like that really makes it something to look into. Basically, any game nowadays uses it just because of the just kind of the cost savings. They still use real-time lighting, but there's a lot you can get like visually out of the real-time lighting. So we'll just do kind of a quick example of it. We'll get rid of the particle system because it's kind of annoying, and we'll move this back down. Okay, just to kind of show you what the light mapping does. We'll just use point lights. Point the light. Whoa. And we'll just get a couple lights situated, get a couple things situated, and we'll duplicate that just real quickly. Just want to show you what it'll do. I'll probably fast forward through this. And before we bake the lights, you have to make sure that the objects that you are baking are set to light map static. Yes! And yeah, so here you can fiddle around with your settings, the scale that they'll show up in the light map. So if you set an object to be say 2 in the light map, it'll get twice as much detail in the light map as something else. Just to keep that in mind. Usually it's good to just keep it at 1. It'll keep everything consistent. And in the bake settings, you can choose what type of light map you want. So single light maps will just create one individual light map for basically the difference between single light maps and dual light maps is the detail of them. Single light maps will just be your regular old just detail. It'll basically be your high detailed light maps. All the shadows, your baked shadows and lights will be there. Your dual light maps kind of it lets you get away with a lower resolution at a farther distance. So things don't need to be as detailed as when they get far away, obviously, because you're not going to see it. So it lets you bake a much lower resolution light map based on the distance that you're going to be away from it. It basically just speeds up rendering times and all that good stuff. You can change your quality for high or low, just how grainy you want it to look. Bounces is basically something that simulates light bounce. When light strikes an object, some of it gets absorbed, some of it gets reflected back into your eye, and then some of it keeps going. So this simulates that. It lets you get a more realistic view of what the lighting in the room would actually look like. Skylight color is basically just it basically shines light from all directions onto an object. It just kind of smooths the light maps out a little bit, so they're not quite as poppy. The intensity is just the intensity of the skylight. You crank that thing up and it'll just, blind you. It's usually alright to keep it at like 0.5 or something. With light mapping, it's something you have to fiddle around with. There's no one specific setting for it. Bounce boost is basically just if you crank that up, it'll increase the amount of light that's bounced off of an object. So you can get cool effects with it. Not realistic effects, but if you're trying to get like a science fiction-y kind of glowy something, the bounce boost could be something you fiddle around with. Same with the bounce intensity, it's just the amount of light and how intense it is that bounces off. Final gather rays is the amount of rays that are kind of sent out. The way light mapping works is a light will send a whole bunch of rays out, figure out where they're bouncing to, where they end up, and that'll determine the color of the object or the color of the light and the intensity of it at any specific point. So the higher it is, the more detailed it'll be, but you crank that up and it'll take a lot longer to bake the light maps. So it's kind of something you have to fiddle around with for the amount of detail you want and how long you want to spend here baking your light maps. Contrast threshold is basically just how smooth or how sharp the shadows to light are in the light map. I normally don't have to fiddle around with that setting. It's usually pretty good where it is. So it's something you would want to experiment with. And the interpolation is basically just how smoothly things blend together on the light map. When you have multiple lights in the scene, sometimes light will overlap each other on a single object. So it just kind of determines how smooth they blend together. And ambient occlusion, you can bake ambient occlusion in your scene. If you don't know what ambient occlusion is, it's basically it's shadows where objects meet. That's kind of the best or easiest way to explain it. When you have, say, a wall and a floor meeting, it's usually a little bit darker in the corner there. And so ambient occlusion will simulate that, and just kind of it makes it look a little bit better. It makes things kind of meld into each other a little bit nicer. That's kind of the best way to explain that one. The resolution is just how detailed the light map is going to be. So 50 texels per world unit is basically like saying how many pixels there are per world unit. So a world unit in Unity is a meter by meter square, so it's going to be 50 per every meter by meter square. And padding, is just how much space is going to be between each object on the light map. So as you bake it, you'll notice that all the objects are unwrapped onto the light map, and the padding is just how much space is going to be between them. If you put 0, they can go right up against each other. If you don't like that, you can create padding between the two. That way, as you get farther away and MIP maps start to degrade the quality of the texture, there won't be bleeding into each other. That's basically what the padding is for. And then the maps is just where you view things after they've been baked. So if we just bake the scene, sure, we'll save it. Random letters. And it's baking still. Okay. I was going to say. We'll just wait for that to bake. Today it's importing light maps, and you'll see that everything is lit up. And now I can actually view the maps. Really tiny, but I can view what the maps look like. And I can actually even take away the lights now, and the scene will still be lit up, because the light is actually baked into a texture that's being overlaid onto every single object in the scene. So, like I said, it lets you get lighting within the scene without the lights, which can get expensive if they're on a lot of objects, or if there are a lot of lights within the scene. Alright. Next is occlusion culling. Okay. Occlusion culling is basically a system set up to completely deactivate renderers of an object when they're outside of a camera's visibility range. So by default, if you're not using Unity Pro or you don't have occlusion baked, Unity uses frustum culling. So a frustum is basically this little rectangle-y pyramid type thingy that shoots out of the camera. That's the camera's frustum, and that is what the camera sees inside of. So anything within this frustum will be viewed and rendered by the camera. Frustum culling means that if the object is outside of this frustum, it won't be rendered at all. It'll be basically like the object's not there. Now what occlusion culling does is it builds volumes around your scene, and if a volume is hiding a volume behind it, everything within that volume will be turned off. Kind of a bad way to explain it, but basically what it lets you do is it lets you turn off objects that are within the frustum, so even less is being rendered when it's not being seen. So for example, if you had a large city and you had occlusion culling baked for it, and you're reviewing a large skyscraper right in front of you, every single object behind that skyscraper will be turned off, because the skyscraper is occluding every single object behind it. It's taking up your entire view, and so nothing else behind it needs to be there, so it's all turned off. Basically, it speeds up rendering at the expense of CPU time. Usually it's, for the most part, occlusion culling comes in handy when you have large scenes and a whole ton of detail in them. For small scenes, it's not really necessary because there's not a lot to worry about. When I'm talking large scenes, I'm meaning like huge terrains. If you're inside like an office building, for example, large as in there's a lot of assets and multiple floors or something. Basically, when there's going to be a lot of objects that aren't necessarily going to be seen at the same time, you're going to want to bake occlusion culling. And I will make a whole ton of cubes here just to kind of show you what it does. Sure, why not? We'll just make a bunch of these. Alright, and then to bake occlusion culling, we're going to set occluder static and yes, sure, we'll change it all static. Easiest way to do it. If things need to be changed, you can do it that way. We'll just set it to static so we don't need to fiddle around with the settings anymore. But if you want to know, occluder static is something that is going to be blocking other objects, and occludee static is something that is going to be possibly be occluded. So for example, a building or a solid object is going to be set to both occluder and occludee because it's going to be blocking things behind it, that sort of thing. A wire fence or something is going to be set to just occludee static because you can see through the object, so you don't want it to block, count as an occluder and turn off everything behind it. So that's basically the different cases that you would use the two. Occluder is when something's going to be completely blocking anything behind it. Occludee is something that you can see through, and it can be occluded, but you don't want to occlude anything behind it. So yeah, they're set to static. We're going to go into the bake settings. Smallest occluder is basically just the size of the smallest object you're going to want to occlude. That depends on your scene. For the most part, the default parameters are good. You're going to want to tweak them depending on your level and what you're doing, but yeah, for the most part these are going to be okay. The smallest hole is going to be the smallest hole that you can see through. So the smaller this is, the more accurate the occlusion culling is going to be, but the more expensive it's going to be and the more data it's going to store, so your levels are going to get a lot larger as well. And the back face threshold is basically just how the occlusion culling handles back face culling. When it's set to 100, it just leaves everything as it is. When it's set to, say, 5, it'll reduce your data based on what is a back face. So if you have this set to 5, for example, and something is occluding something behind it, and you're looking at its front, it'll occlude it perfectly fine. But if you turn around to the back and the back face is invisible, it'll still continue rendering things as if it was never there. But if you set this to 100, it's going to still act like an occluder, and you won't be able to see anything that was there. So we'll just bake this really quick so you can see what it does. So you see right here it's creating all the volumes. So these are all the occluder volumes. And now we're visualizing what the camera is seeing. So the main camera only has these 3 objects in its view frustum. So the other objects are completely turned off. And as we move back, you'll see that as they enter the frustum, they start getting turned on again. So basically what it does is it completely turns it off, so there is less for the camera to have to use its algorithm to figure out where objects are and whether or not they're actually in the camera frustum, and it speeds up the rendering. And that's basically occlusion culling. And then last is navigation. And this is Unity's built-in nav meshes. So for pathfinding, for your characters or NPCs or anything like that, for the most part they're going to be using some sort of pathfinding system just to kind of move around. So there's multiple different ways to do pathfinding. a lot of people do node-based pathfinding, which is just points in the world that characters can walk to. There's grid-based, where you just create a grid of points and they can maneuver through the grid. And the version that Unity has is called nav meshes. Basically what it does is it analyzes the scene, figures out what points you have set to walkable and not, and it creates a mesh over top of the scene that the characters can walk on. So instead of having to search through a whole ton of points to figure out the best path to the location, it can just figure out which triangles of the mesh it needs to walk on, and it can use the entire triangle of that mesh as a walkable area instead of just point to point. So it's not too shabby in that area. It's usually a lot more efficient. It's a lot better to have, say, 20 points to walk to and do a couple raycasts to figure out where you are on the triangle than it is to have, say, 1,000 points that your character has to walk through. Memory-wise, it'll be a lot more efficient that way. And basically, if you want to generate a nav mesh, you just make sure that the object, or any of the objects that are going to have the nav meshes built or baked onto them, are set to navigation static. And you go into your navigation window there, and you can change the settings for the navigation mesh. Radius and height is basically just going to be the radius of your character and the height of the character. It helps calculate how far away from an object the triangle should be created. In your max slope is going to be the maximum angle of a slope that your character can walk on. So basically any object in the scene that is under, say, the 45 degrees here, it'll create a triangle that is on an angle so the character knows that it can walk on it. But if it's above that, the triangle will stop. It'll basically create a step that your character can no longer walk on. And the step height is basically just the maximum height. So let's say you have a set of stairs and they're, say, 0.3 in height. It'll create a angled triangle across the entire stairs. But if you have the stairs too steep, or you have a couple ledges that are above your step height, the triangles will stop, just like with the max slope here. It'll stop so it doesn't generate the angle triangles for your characters to walk on. And the off mesh links is basically if you have specific parts of your level set up. Say you have a ledge that you want your AI characters to jump down, you can create an off mesh link, and so if the max slope or the step height is too high to connect the characters together, you can create a mesh link so that the characters will know to jump down off of the ledge and then keep doing their thing. And you can also create specific layers. So if you only want certain characters to walk a certain path, no girls allowed, you can set up specific layers for your navigation so characters won't know or will know not to go a specific way. It's good for controlling your AI, or if you have a base set up that's the safe zone, like I said, no girls allowed, or nanner, you're it, you can't get me in the home, or home free. You can set it up that way with your navigation layers. And just to bake it, you just make sure that your stuff is set to your navigation static, and you hit bake, and it'll export everything. And as you can see, it creates these meshes that go over top of it, and your character will be able to run anywhere between these triangles. Oh, and I just disappeared. There we go. If you're wanting to use the navigation meshes with your characters, you need to attach the nav mesh agents to these characters, and then using the nav mesh agent, you can set up all of the details for your character let them know where they have to go, which layers, the height and everything, and then the nav mesh actor or agent will be able to figure out the pathing and all that stuff on its own. So it's good there. And then that was the window, so that took up I don't know how long. Yeah, so those are basically your windows, what the window menu is for. You can also open up the console, so any debug logs or anything like that will show up in the console. Good for your debugging scripts and any errors that come up. Alright, and last is just the help toolbar. And basically you can figure out what version of Unity you're using. You can add or remove or change your license for Unity. You have easy access to the Unity manuals and the forums. You can manually check for updates, and if you found a bug, you can report it. And that's basically what the help menu is. So, hopefully you found this useful. I know sometimes I need a second try to explain things the right way, but hopefully you kind of have a good grasp of what each window does so far. And yeah, that's basically it for now. So bye bye.